Anyone who hasn't met Tavis at any of the Wisconsin Mycological Society forays, he is one of the key ID people at a lot of those forays, and we really appreciate having him in such close proximity. He's been a mushroom enthusiast for most of his life. His father started teaching him mycological identification when he was really small, and he's now a 35-year veteran of cultivation and identification in Northwest Wisconsin and is passing on his love to others. He is a mycology instructor for 22 schools in the upper Midwest and has been teaching for about 12 years. He's the author of Mushroom Cultivation and co-author of The Beginner's Guide to Mushrooms. He specializes in the genus Russula and several other genera. He's active with the Wisconsin Mycological Society and founder of the Northwestern Wisconsin Myco Enthusiast Club. And then an active contributor to everything mushroom related in the Midwest. You can find him on Mushroom Observer and iNaturalist, where he is a big contributor there. So welcome, Tavis.
Well, thanks, everyone. Thanks for having me here today. But my name is Tavis. I've been chasing the wild mushrooms of Wisconsin since about 1980. So I kept a journal from 1987 until today of every mushroom I've ever found and photographed. Pretty nerdy. Some of it pretty useless, but I do it anyway. But today we're going to concentrate on the genus Russula. Russula is a project, we'll say, and it's a project in progress. We're getting better at this. This is a quote from the old illustrations of British mycology that I opened this talk with. I think it's great. It kind of explains really what we're going to look at tonight. I am not going to solve all of the Russula mysteries in an hour for you. I'm really not. In fact, it might end up being maybe more confusing at the end. You might say, I know less now than I did when I got here, but it might clear some things up. So why Russula? Well, I don't want to be the Russula guy. I never did. Because what had happened was I was teaching for a continuing ed program, and the lady said the director, she wanted something different than the classes I was teaching. She said, we're saturating it. We've done it for 10 years, mushrooms of spring, mushrooms of summer, whatever else. So she wanted to do a continuous kind of course in study and go genus by genus. And the first one she picked was the obvious one. That was Amanita. Okay. And these were all like 1 hour programs. And the second one she picked was Russula. And I always wanted to be the waxy cap guy. I've always been fascinated with hygroscopy and its allies, and I still am. But what had happened is in 2013, Britt Bunyard Googled my name, and the first thing that came up was Russula. So he thought I was some Russula expert. I'm not. I'm still not. So they started calling me the Russula guy. So after a few years, I just decided to embrace it. In this photograph here, these are all on a very short stretch of one of the trails on Madeline Island. How many species are in this picture? That's really hard to say. I'm saying somewhere between 6 and 13, and we'll make a little bit more sense of that coming up. So who is Russula? And I don't care how you say it. I've heard it pronounced Russula and Razula and Russula, Rochella. I heard a guy call it Rochella. I say Russula. However you want to is just fine. But Russula is in the family of the Russulaceae, which makes sense, and in the order the Russulales. But it's the misfit of that order. This is what we would expect. Small, colorful, often very fragile forest floor mushrooms, very common, a wide variety of colors. But the Russulales as an order mostly contains pored fungi, some crusts, some toothed fungi, some corals, some mushrooms that we wouldn't associate with Russula. The Russulales is probably the broadest as far as morphological differences go. Like this little Oroscalpium. This is a little toothy mushroom, grows on pine cones. What's the other one? Gloiodon, another toothy mushroom that grows on woody debris. They don't look like Russula. They don't look like they should belong in the Russulaceae or the Russulales, but they do. Artemisias, one of our favorite spring edibles, at least one of mine. I think these things are great. This is in the Russulales. Our little booger crusts, the Piniophora, Russulates. None of these look like what we would think of Russula. Bonderzephia, that's in the Russulates. So the Russulaceae, containing about 15 genera of gilled mushrooms, is truly the misfit of the order, even though it's named after this genus. There's about 15 genera within the Russulaceae, but the ones that we're going to see most commonly are obviously going to be Russula lactifluus and Lactarius. Today we'll be concentrating on the genus Russula. So what is Russula? Well, they are terrestrial. I'm sure we all know what that means, but that means growing on the ground. You're not going to find Russula growing on wood, though you sometimes will see on very decomposed logs. There's a couple of forest species of red Russula that will be growing, I like to say growing through it and kind of using it as a water cell rather than actually getting their nutrition from the decomposing wood. So we're going to call them all terrestrial. They're also all mycorrhizal, sharing a bond with a vascular plant, typically a tree. I have seen them with blueberries. And are they mycorrhizal with blueberry? I doubt it. There could have been other trees there that they were bonded to, but they are certainly mycorrhizal. They're fragile, but not all of them. And that's due to a structure within their tissue called a spherocyst. And it's exactly as it sounds, it's a cyst that's spherical. And that is a sterile cell that just fills up with water so that the mushroom can grow very quickly. I don't know if I've got Russula tenuiceps in the program tonight, but that mushroom can grow to full size in just a matter of a couple of hours because of those spherocysts. But the spherocysts make them extremely fragile. It makes them, I mean, some of them are hard to handle. Some of them are tougher than others, and they are wildly unpopular, which makes me wildly unpopular when I start talking about Russula. Beginners do like to look at them, but the fascination fades after they can't find value in the mushroom. What I'm referring to there is the classic can I eat them? I know that when most people get into mushrooming, it's for free food, right? You know, we like the taste of wild mushrooms. It's not why I'm into it, and I apologize to anybody I've been short with for asking me, can I eat it? It's like, you know, there's other things we can do. We can look at them, we can take pictures, we can study them. But the beginners, yeah, they're in it for the food, and I get that. More experienced hunters start to ignore them because they're difficult to identify, and some of them are right next to impossible to distinguish from each other. So, but some of them are very easy, and we're learning as we go. We're learning different tricks. So, what I was seeing at all these events, you know, I don't know how many events the WMS has had this year, maybe a dozen already, and I've been to I think five. But now we're doing better than we used to because when I started, I've been a member of the WMS off and on since I think like 1996. I had several years where I was not active, but I would go to these events and they're counting species, and all they were doing was Russula was piling it up. They didn't talk about them. They just said, "Oh, that's the Russula dump, the Russula pile." That kind of bothered me. So as I'm embracing my role as the Russula guy, I've seen kind of an evolution of the species list, at least within the Wisconsin club, because it used to be Russula in a pile, ignored. That's the Russula dump. And then I said, well, we have to count them. You know, everybody's trying to pad their species lists and get these, 300 and 400 species lists at a retreat, or even 100 at a day foray or something, and they're not counting those. Well, count them. So we were starting to see tags of Russula species plural. Maybe putting all the red ones together and calling them one. Fine. Then we started to get a little bit better as we were starting to see some differences, and we started attaching numbers to them. So at least we had them recorded. And then these, of course, are always collected if we added a number. So an example here is Russula species Hiles Foray -01. Hiles is the mushroom capital of Wisconsin. It's about an hour south of where I'm at right now. I'm actually in Upper Michigan right now in Iron River. We've got a large event there this weekend. This is how we kept them and counted them, I should say. Then, with a few years of practice and starting to recognize a few of these, we were able to get them down into subgenus or section or even subsection, and in some cases, species. So we had a better way of counting them. So, like we had one yesterday, I knew it was Russula in section Russula, and we added DEC-01. That mushroom got collected. That is Dells of the Eau Claire. That was our foray yesterday. We had a Sunday foray. So we're getting better at that, and I think that's important that we're recognizing these mushrooms for individuals rather than just a big ignored clump. So many of the names that we are using are borrowed European names, and that's not just for Russula. We know that the names are constantly changing, and that's because we're finding out that the literature that we're basing all of our knowledge on is kind of exclusive to Europe. So I'm using those names so that we are attaching something to them, but it's really not perfect. I'm not going to say it's incorrect because we have to call them something. So we have these little clipperds. You'll see these occasionally between the generic and the specific. The first one being Aphanis, AFF, which means related to. So if I have a mushroom that I know is close to another species and I know it's not that, we attach Aphanis. I'll give you a couple examples in a moment. And this is the way this was taught to me. I know this isn't probably out of a dictionary or anything. And then we have CF or confer, which means compare to. This means that we know it's close to that name that we're using, and it actually could be that mushroom. So a couple of examples, Russula AFF Zavari Aphanis, related to. I know that we don't have Russula Zavari in the United States. That is a southwestern European mushroom, but we do have a mushroom here that is morphologically identical. So when we record that, we put Russula AFF Zavari. Now we have that mushroom name. This mushroom likely doesn't have a valid United States name, or North American, I should say. Then our other example here, confer or compare to Russula CF cyanozantha. Cyanozantha is definitely a European species. We have one in the United States that is identical. So we say Russula CF cyanozantha. That means, is it cyanozantha? It certainly could be. We know it's not Zavari, but it's close. It could be cyanozantha, and it's close. That's how that was explained to me. So Rolf Singer, a few decades back, divided Russula into sections, and this was super cool because it was easy, and I used this system for 20 years. As how I would sort them out in my notes. If anybody's ever seen my notes, it's kind of cool. I like them. It's the spreadsheet of everything that I've done since '87, with 15 tabs on a Excel spreadsheet, whatever you call it. So I was sorting them that way, and this was great because it went on features that I could see with my eyes or my nose. And you can't see with your nose, but you know what I mean. So he divided them into the ingrati, the declarantes, the rigidi, the compacti, and section Russula. So breaking these down, this was Rolf Singer's plan, and I wish it would have worked. It didn't work genetically, unfortunately. It worked morphologically, which was something. So section ingrati, this is what we call our stinky Russula. We're going to go through 3 different systems today. We're going to go through this one, which is kind of obsolete. Then we're going to go through a key system. Then we're going to go through the current infragenerics. So section ingrati, this is the ones that have the odor of bleach or almonds. Some people say they smell soapy, or maraschino cherries, which is just almond extract anyway. Some of them being more to the bleachy side, some of them being more to the almondy side. Some of them smell rather pleasant. Some of them really don't. And I'm not a huge fan of the odor in the first place because I do get that bleachy note on most of them. The cap is typically straw colored to a pale reddish brown, and they do have some bruising, especially on the gill tissue. If you crush the gills with your fingers, you'll see some, reddish brown or pale gray staining. And if you do the old taste and spit on these, they're going to taste oily to acrid, not super acrid, but a little spice to them. And these were always said to be avoided for the table. So anything that has the acrid taste or has that bleachy almond smell could be a little bit of a gastric irritant. Section declarantes, these are a little bit more sturdy. They are very colorful. We're going to look at a couple examples of each of these as we go, as we get further into the modern sections of this. Uh, Lots of purples, lots of reds and oranges and yellows, but all parts bruising gray to black or pink to red to black. Russula declarantes. What did I find today? Russula clariflava. You know, it's a really pretty white mushroom, but when you handle it, it does discolor. And the spore print is variable, anywhere from stark white all the way up to kind of a mid ochre color or any kind of yellowish orange in between. Section rigidity. This was what we would call our edible Russula. And we're going to talk about edibles towards the end. These were always with a dry cap. It was never sticky or slimy. Sometimes prunos or crustos. Prunos, I've got a picture of that coming up. That's that really light powdered sugar dusting that we see on some species, a couple species, not very many. Or crustos, meaning it has actual crusty patches. Everything in section rigidity, according to Rolf Singer, had a cap that was either purple, green, yellow, or red. So again, colorful. With a variable spore print, again, sometimes up to a very deep ochre, almost like an orangey brown. And they have a mild taste or a slowly acrid taste in some cases. I did try one that was in my yard a few years ago that was slowly acrid, and it was edible. It was fine. It wasn't. I'm not going to say it was delicious because it wasn't. It was pretty flavorless. But the ones that are really acrid, those are the ones that we should probably avoid. Section compacti. This got a little bit strange. Russula compacta falls into Russula compacti in this system. Our new infragenerics, it actually doesn't. It falls into subgenus Malodorian. We'll get to that. But back when Rolf did this, it made sense. These are the Russula that are very firm. They always have a white stem. They're never going to show any hint of color or a flush, as we call it. And the gills and the stem always discoloring brown or grayish brown when handled, usually pretty readily. There is no color variation on these spore prints. They're always white. Then we had section Russula. These are the ones that are probably most frequently encountered. This held up. Russula, the genus, Russula, the subgenus, the section, and the subsection. So this one worked. And these are our very fragile Russula with a viscid cap, especially when wet, but they're kind of tacky, very easy to peel the cuticle off the cap. And the cap fades with age. Other sections don't. They hold their color right through death. And the spore color is variable, but you're not going to see the deep ochre orange. You're going to see more of a white to kind of a very pale yellowish tan. I know colors are hard to describe. And these are going to have a very acrid taste, almost all of them. Some of them to the point where it's kind of like licking a 9-volt battery with a little hot sauce on it. So is there something better? The system didn't work with DNA evidence. These mushrooms, a lot of them were grouped together. A lot of them turned out not to be. But it's still a valuable tool. I think it's a nice way to start learning Russula is to learn the Singer program. And then at least for me anyway, it helps me see how they fit into the modern system. So up comes Kibbe and Fatto. They have a key, and I didn't bring it with me. I'm traveling right now, of course, so I can't hold it up to the screen and show you how it works, but we're going to go through a little bit. They came up with a very interesting key for Russula. They actually did one for Lexinum before this that was wildly popular in Great Britain. Is what we're doing is rather than the dichotomous key that we see in most field guides, is it yellow? If so, go to number 1 or number 2. Is it not yellow, go to number 5. It's all yes or no questions. With this, we did a 7-stage, like a multi-tiered key. So we're looking at the color of the cap, and I'm not going to get into what each letter means, but I'll tell you right now, A means red to purple. B means it has some shade of green, I think. C means it's yellow. So anyway, you look at your mushroom and you give it a letter. Then you're pinching the edge of the cap with your fingers and peeling the cuticle towards center. Does it peel all the way? We give it a J. Does it peel like a quarter to halfway or something? You give it an I. Or does it not peel at all? Is it quite adnate? Then we give it an H. Color of the stem. Does it have some? Does it not have some? Cap diameter for the letters M, N, or O, almost all Russula are going to fall into N, which means 4 centimeters to 10. M is under 4 centimeters. O is over 10. Most Russula are going to fall into that regular size. So if you find something that's maturing, at 2 centimeters, it's going to be pretty easy to identify. Spore print color, they have this really cool, and if anybody wants this, I will email this whole guide to them. I do have it, and it's kind of fun to play with. And some of the names are, not valid, but it gets you in the right direction. But he's got a little color swatches of every possible Russula spore color, and you assign a letter accordingly. Then taste is SVU, so it is mild, acrid, or bitter for those 3 letters. And then if there's any staining or bruising, you add the letter V. So here is our mystery mushroom that we're going to look at. And this is found in my front yard. I do know what it is, which makes it a little easier. But going through the Kibbe and Fatto system, the cap is red, so we give it the letter A. The cuticle peels 1/3 to 3/4 the center, so we give it an I. The stem is white. There's no pink to it or red, so we give it the letter K. The cap is 4 to 10, like most of them are. We give it the letter N. The spores of this mushroom are actually a very deep ochre, almost that brownish orange. And the taste is acrid. Slowly so. This is the one that I ate. Slowly acrid, but still acrid nonetheless. We have to count it. And the flesh does not discolor, so I don't add the V at the end. So our final code for this mushroom is AIKNRS. And if you go through the Kibbe Fatto key, it'll give you like 3 or 4 choices of what codes out to that. It's a really cool system. There was somebody in Chicago, and I wish I could remember who it was, rewrote this and added 2 more letters, which was hardwood versus conifer host, which, sure, I mean, we're helping narrow it down. So the final code, AIKNRS, I come up with Russula Corinthia rubra. And I am certain that that's what this mushroom is. I find it in 3 places. 2 of them are actually up here in Michigan, where I'm at now, and then 1 in Wisconsin. So something cool to play with. You can see in this picture the gills are starting to discolor a little bit towards that ochre color, but these mushrooms weren't fully mature yet. The slugs were beating them up, so they don't look as fresh as they were. But the modern system, this is the modern Russula infragenerics. We can't talk about all of these. There are far too many. So this is subgenera. Each of these is a subgenus, the 4 sections. So within subgenus Russula, we have 15 sections. Within the subgenus Heterophyllidea, we have 4 sections. Archaea was not split any further. Brevipedium was, the sections are unclear. There's a little bit of cloudy gray areas there. Section or subgenus Compacti was divided into 3 sections. Crassotunicati, the sections are unclear, but I know somebody's working on that in China right now. So I've got a few papers that I keep getting them and piling them up. I've got a lot of reading to do, but that's what I do in the winter. It's mushroom season now. No time to read. The glutinosi, no further division, and I think only 1 species in the United States, or maybe 2, and then like 3 or 4 in China. So that one was pretty small. The Malidori, again, cloudy. The sections are unclear. And then there's the brand new Cremio I don't know very much about that. I did read the paper on it, and I didn't see anything applying to the North American Russula. So we're going to kind of break these down, and you'll see some similarities, especially around section Russula and section Compacti. But that's kind of where it ends. So subgenus Russula. This is the largest subgenus, containing 15 sections and dozens of subsections. I mean, it's absolutely massive. So most of our red-capped or fragile Russula will fall into this group, but not all red-capped Russula. They're going to fall into a couple others. We've got something ringing in here. That's my friend's child's blood sugar alarm. I hope they figure that out. So we do have red cap species in other subgenera. All of the shrimp scented Russula will also fall into subgenus Russula. And we're going to look at a couple of those. So, a couple examples as we go. Russula betularum. This is a birch associate, very common in the northern half of Wisconsin, probably the northern 2/3 of Minnesota, where we're seeing, most of our white birch trees. It's exclusive to birch. It's always got, and I know it looks pretty good in this picture. I did replace the picture that I had because it kind of looked more orange, and it's not orange, it's a pale red, like a pinkish red. And it's fairly sturdy, but it'll always be in the presence of birch. Hey, that's an easy way to identify this mushroom. Russula decalorans. This is in subgenus Russula. This is one of our what we call decolorantes from the Singer program. So we've got a colorful cap here. This is orange or coppery orange. And we can see a little bit here of that brown to gray staining I was referring to on the gills of the center mushroom. And you'll see it on the upper part of the stem sometimes too. I got to figure out how to shut that thing off. I don't know if you guys can hear it, but it's driving me nuts.
Yeah, we can't hear it.
Okay, good. It's awful. I assure you, it's awful. Very similar looking to decalorans is Russula fulvescens, and these get mixed up in the field a lot because the colors are the same. They've got this coppery orange color, but this mushroom will not discolor with handling. You won't see the grayish staining on the gills or the top of the cap. So sometimes to identify a Russula, you have to wait a little while. Crush a piece of it with your fingers. Maybe take a slice and see what happens. So this was Decolorantes. It falls into subgenus Russula. Russula zarempelina. This is a complex. I know this isn't zarempelina, but this is the shrimp Russula that grows in Colorado. So the shrimp Russula that I see in Wisconsin are actually more of like an orangey purple, if that's a color. They don't have this pretty deep purple. Another one that we encountered in Colorado a couple years ago was olive green, and it had that beautiful seafood smell. We ate them; they were great. This is one of the exceptions to Russula being not good edibles. Russula zarempelina complex is very good. And anything with that odor, especially dried, you'll notice it a lot more if you run them through a dehydrator, put them in a bag, open the bag a couple days later, and they are quite potent, but pleasant. The second subgenus up is the Heterophyllidea. So this is where we're going to find most of our green Russula. There's 4 sections within it. Section Ingrati being one, which was one of the Singer sections. He was correct on that. And we're going to find a lot of red ones too, but these aren't going to be super fragile like section or subgenus Russula. These are going to be more of the almost like greasy feeling or rubbery feeling. And Ingrati looking less like others in this section. We're going to look at a couple here that might be familiar. First one up to me is one that really stands out, Russula marii. This deep purple cap and this usually heavily flushed stem. If we look closely here, and I was in the woods for 2 hours today looking for one of these just to get a better picture of the prunos bloom. But this is the mushroom I think of. So this is in section Amininae within the Heterophyllidea. But we can kind of see there's a little bit of a dusting on it still. It's just like somebody took a tiny bit of powdered sugar and just barely laid a thin layer on the cap. Russula variata, I was looking for this one too. I missed him in my yard by a day. I wish I had a better picture of this mushroom. It's one of the most common Russula. It's in my front yard for 3 months out of the year, and this is the best picture I've taken. No excuse for that. They're modeled. They look very similar to Russula cynoxantha, though I do tend to see green being more dominant in variata and the pinks and reds more dominant in Russula cynoxantha. But one big difference between them is the gill forking. So if we look at the gills of variata, they don't just fork at the margin or at the base of the stem. They fork throughout the field and they fork often. And not very many Russula do that. Variata is the one that really stands out with the forked gills. It makes it a very handy tool for identifying this mushroom when you're having questions. Flip your Russula over and look at the gill forking. You'll notice when you find Variata, it is very distinctly forked throughout the field of the lamellae. Versus this is what we would see in Russula cyanozantha. No forking. That is gill from one edge to the other. There's no splitting anywhere. So, yeah, do they look the same from the top? Absolutely. You know, they can be modeled with yellows and greens and pinks and purples and reds, but if we flip them over, suddenly it becomes a lot easier. Russula grata. This is from section Ingrati. This is our stinky Russula. This is the most common one in the upper Midwest, though we do have quite a handful of species. What's interesting is Rolf had this as section Ingrati, and the three species we're going to look at coming up here, all three of them ended up in different subsections. They weren't quite as closely related as maybe he thought, but these are the ones we can see. A little bit of staining here. I think my arrow works. A little bit of staining here where I probably crushed it with my thumb, maybe a little bit on this stem, and we're seeing that straw colored cap. Russula pectinatoides tends to be a little bit darker. The margin tends to be a little bit more sulcate, which is just striate with actual dents that you can feel. Striate, you would not feel them. And Russula aminolens, which tends to be a little bit more on the gray-brown side. All three of these fall into section Ingrati, but they actually ended up in three different subsections. I mean, Russula really is complex. And where do you draw the line? I mean, you could just say we can stop at section, but no, we got to nitpick, right? Subgenus Archaea is the oldest lineage of Russula. It has not been divided into any sections, and the most frequently encountered species is Russula earlii. I have never seen that mushroom, so you get a picture of Chuck Norris. It grows too far east of here. Its range only extends to about Ohio, as far as I can tell. So I'm hoping this autumn they will still be in fruit when the Namaphore happens. I will be attending in Vermont, and I will be examining their local Russula. Subgenus Brevipedum. Within that subgenus, we have section Lactarioideae, which is the Russula that looked like Lactarius, or Lactifluus is more accurate there. This is Russula brevipes. Russula brevipes looks exactly like Lactifluus deceptivus, and that's why deceptivus has its name, deceptivus. It's deceiving you into thinking it's Russula. One cool trick is even if Lactifluus, if the latex is scant, there's a great way to tell these two apart. Take just the very tip of your knife and cut across the gills. So you're cutting multiple gills with one stroke. With Russula brevipes, you will hear an audible snap as the knife pierces each gill as it's cutting through. Whereas Lactifluus, it'll slide through like it's been lubricated. It's kind of cool. I do that demo in the woods for people where I'm like, which one's which? And they, boy, sometimes you can't tell them apart. Run the tip of your knife through them. There was a little debate a couple years ago on whether Russula brevipes even belongs in Russula or if it belongs in Lactifluus as a Lactifluus that doesn't produce latex. But now this subgenus Brevipedum, section Lactarioideae, was erected for basically Russula brevipes and its variants. This is Russula brevipes variety acreor. We can't see it very well, but right here, there is a little hint of blue. These were pretty dried up. I've seen it, though, where there's a blue ring there that is just as blue as can be, which is a distinct feature of that. So these used to be in section Compacti, but it didn't work genetically. We split again. So subgenus Compacti, this is the subgenus that contains mushrooms that stain either gray to black or pink to black. And I saw both yesterday. All of them will produce a pure white spore print. It will never have any color. And it is divided into three sections. So Russula densifolia, probably the most commonly encountered. Densifolia means dense foliage. That means the gills are packed together very tightly, more so than really any other Russula. This has really tight gills, very crowded. if we look right here, I have cut the edge of this mushroom to illustrate the color change. And we see it's kind of going through like a brownish gray stage, and eventually it will blacken. And they blacken in death too. This is Russula dissimulans. This is one of the ones that came in yesterday. Very similar from the top, kind of that dirty grayish brown color. But we notice the gills are spaced out quite a bit further. And on this top right one, I sliced the edge of this cap off. And before it turns black, it goes through this rosy pink stage. So we're seeing a little bit of a different color change between gray to black. Now we're going from pink to black. And that pink just keeps getting darker and darker until it's kind of like a, I don't know, dark reddish, like a reddish brown, and then eventually black. Subgenus Crassotunicati, again, sections are unclear. Two notable species are Russula farinipes and Russula crassotunicata. I've never seen either one of those either. I would expect that they could be considered rare or non-existent for most of the United States. Well, I shouldn't say that. Farinipes, I think, has quite a few observations on the eastern seaboard, if I'm not mistaken, on MO and probably iNaturalist too. I don't use iNat as much. Subgenus glutinosi. This subgenus contains one species in the United States, as far as I know, seemingly rare. I did check iNaturalist for this one, and I should report this one because this is certainly glutinosa. There's no division into sections. I know that there's 4 more known species in China where they're doing a little bit more work on Russula than we are. We're getting there. And then subgenus Malodori. Malo meaning bad and odore meaning odor, bad odor. So this is a subgenus where the sections are unclear. It didn't work out. This was formerly in subgenus Compacti according to the Rolf Singer program. This is Russula compacta. It does not fit into Compacti as a modern subgenus. It fits into the Malodori, the bad odor. And I had never heard this until I started using iNaturalist only like a year ago. I'm not real familiar with it. I put a lot of stuff on there. But it's referring to it as the fish biscuit. I have never heard that common name before. It's funny. Here we can see where I cut the gills. They did discolor that brownish color. These gills are certainly discoloring. These can get quite large too. And I'm kind of wondering if someone needs to take a look at Russula compacta as a species, because I think it's probably a species complex. Some of them that we find up near Bayfield, Wisconsin are downright enormous. Some of them approaching 10 inches across on the cap, like huge mushrooms. Oh, why did that quit working? There we go. Russula compacta. So here we can see a little bit better image. Definitely the bruising where I handled it. Kind of this, beige, kind of pale color. These are super dense. They are not fragile. So when you're handling them, you might think you're holding, maybe tricholoma or something that's a little bit tougher. But they're definitely Russula. They just don't have that classic crumbliness that other Russula have. And they're slower growing. They don't pop up overnight like most species within the genus do. So subgenus Cremio-Ocraceae, this is the newest addition to the list of Russula subgenera, and it was only erected, I believe, last year. And I know very little about it. I know that there is a couple of Chinese papers on it. I know nothing about its existence in North America, but it is the 9th subgenus of Russula. So what's the best we can do in the field? Obviously, we can use our eyes. We can use our nose, So color, well, that's a little bit debatable. So one group that we didn't see much of today was red-capped Russula, the legendary, difficult to identify red-capped Russula. So how many are there? I've heard people say there could be up to 130 species of red-capped Russula. The more that we dig into this project, the less red-capped Russula we're finding, because what was happening was There's so much morphological variation within a species that one species was getting called 8 different species. So when they say 130, I think it's probably closer to about 40 or 50. And I could be dead wrong on that, but the more Russula that I look at, the more I'm starting to see these are just really variable. So a lot of these descriptions that we're getting from 100 years ago, it's 5, maybe 10 different mushrooms or the same mushroom getting that many different descriptions. So, and maybe I'm way off on that. Maybe there's 200, but I think it's going the other way. I really do. Spore print. I've got a really crappy picture coming up of the variation of Rushla spore prints. I'll do a better one this year. I never thought I would have to have a slide that had that on there. But the spore print, I've seen one mushroom print 2 different colors. So it's probably an issue of immature spores dropping. They're probably maturing to a color, or maybe there's just that much variation in the color. So we'll figure these out as we go. Odor. There's a couple of odors. One of them is, of course, that bleachy almondy smell that it's distinct. You'll never forget it. Like I said, some people enjoy it. I don't. I think it smells like a swimming pool. And then there's some oily odors too. And I've had people say, what like motor oil? And I'm like, no, more like vegetable oil that's kind of gone rancid. If you've got an old bottle of vegetable oil somewhere in the house that maybe been there for a couple of years, I do. Give it a whiff. You'll know what I mean by an oily odor. Uh, Taste and spit. I think most of us know that that's safe to do. Give it a taste. Is it bitter, which is not common, but it can happen? Is it acrid? And boy, when you run into a hot Rushla, and a few people I saw in the group here, I've spent some time in the woods with, and I'll cut a little slice off sometimes of a bitter bolete or a spicy Rushla for people to try. It's hot. It's got that. It's not a pleasant hot. It's not like a hot pepper. A hot pepper tastes good. This tastes like 9-volt battery. I mean, it's a very bizarre, awful taste. Peeling of the cuticle. That I don't know who came up with that. I don't think it was Rolf. I think it was done before him. And I could be mistaken on that. But you're just pinching the edge and peeling towards center. I've got a picture illustrating that coming up. And then chemical reactions. Lots of cool chemicals out there to play with Rushla. Season. Rushla vinacea, that season is almost done. That's one of the first Rushla to appear and the first to disappear. Some of them are out in mid-June and they'll run through, the end of September. Some of them don't start till the end of September. So that can help us narrow down what we have. The margin, is it smooth? Is it sulcate? Is it striate? Is there texture to it? Is it flared upward? Little things we can take note of. Size, and with size, that seems to be regional. The further north you go, the larger Rushla get. And I don't know why that is. I had a theory. I didn't have this theory. Somebody told me this a couple years ago, and I'm not quite buying into it, but I thought it was really interesting that they came up with this idea. They said Rushla up north have to be larger to produce more spores because the season is so much shorter. And they said it with confidence. And I just looked and smiled and said, I think that's probably not true, but maybe it is. Who knows? But they do tend to be larger the further north you go. I've picked in Illinois. Their Rushla don't get very big. I mean, some of them will, but not like they do up here. Rushla get enormous up here. Shape, there's not going to be a lot of difference in Rushla's shape with the exception of the Lactarioideae of subgenus Brevipedum, which has more of that Lactarius lactifluous stature. The rest of them, they're kind of all shaped the same. But gill spacing can be important. We're going to look at a method I came up with for measuring that. What is the host tree? I know that I've probably told several people, even in this group, that look at what tree is hanging around. It's very important to know if it was growing with a hemlock or a birch. This can help us identify. Stem flush. Stem flush is hard to see sometimes. You've really got to look, maybe even grab a loupe. If it has any hint of color, we consider that a flushed stem. Any hint. And sometimes it's quite readily visible, but sometimes it's hard to see. We've got a trick for that coming up in a second. Soil type. We've got one we're going to look at very soon here that grows exclusively in sand. Some of them less picky. They're more interested in what trees are present. Elevation. Most of what I've done with these is certainly in Wisconsin because that's where I live. But I did do 6 or 8 years in the Rocky Mountains, and I noticed different russula at different elevations, but that's because there were different trees at different elevations. So we were finding some with cottonwood down by the rivers, and then we were finding some with Engelmann spruce up at elevation. Yeah, so elevation, probably not what the mushroom is choosing, it's probably what the tree is choosing. And if we want to go a little farther, you can break out the old microscope. Russula spores are exciting to look at. They're not boring little discs or ovals. They've got a lot of texture, a lot of character. And then, of course, DNA sequencing. That's supposed to be the be all end all, but not everybody has access to that. But that'll be the final chapter, I think, as we start. We got to do some field work first, I believe. So here's that garbage picture I told you about. So on the left, we have a spore print that is white. That's as white gets. Over here, we're seeing that, and I just pulled a piece of foil out of my archives just to snap a quick picture because I needed it immediately, and it was mid-February when I had to do that last presentation. So this is what you get. But this shows that ochre color I was referring to. Kind of that beigey, tannish, orangish, whatever, ochre. So any color in between too. And even darker than that. I didn't grab the darkest one I had. Odor and taste. We talked about that a little bit. Give them a little nibble. Give them a sniff. I'm not as good about this as I should be. Our current president of the WMS, Mariah Rogers, she's great. The first thing that she does when she picks up a mushroom is flips it over and smells it without really even taking a good look at it. I got to get into the habit of doing that. Russula odors are important and tastes too. But boy, the tongue gets kind of numb after a half a dozen spicy Russula. Might ruin your day. This is the peeling of the cuticle, a blurry picture I probably took with a cell phone. But we can see that this cuticle does separate from the cap flesh. So if we peel that towards the center, how far does it go before it breaks into a triangle? And age of the mushroom will affect that. I was asked the last time I ran this program if heat and humidity did. I haven't noticed that as much. It's definitely the age of the mushroom because when they're old, probably all of them peel. So you want one that hasn't, completely flattened out yet. Because I've grabbed Russula that are completely mature, went to peel the cuticle and peeled the entire cuticle off. So now I just have a white mushroom. So get them when they're young. It's not a perfect system, but it is kind of interesting how the different species do tear differently. Chemicals, Fesophore, KOH. These do some things like erasing colors or turning some greens to oranges. But the really cool ones are guaiac and PDAB. So guaiac is a chemical I got in Colorado a couple years ago. I had never worked with it before. The method for working with it was actually written in, I think, 1916. So it's been around for 100 years. I never did it until last year. What it is, well, it's used in the medical profession actually to detect blood somewhere. We won't talk about that. It's kind of gross. But what's cool is it reacts with, I believe it's a certain protein in the mushroom that this coffee colored, brownish fluid turns blue. So we've got 3 levels of blue. Does it turn blue, from 0 to 30 seconds? We call that a fast reaction. Does it turn blue from 30 seconds to 4 minutes? We call that a slow reaction. Does it not change at all or change after the 4 minute mark? We call those all negative. So I was starting to separate some red Russula based on how they reacted with guaiac, which was kind of cool. PDAB will show stem flush even if it's too faint to see with the naked eye, which is very cool. So if you've got a bunch of species that have pink, or a bunch of specimens that have pink stems, they were all growing together, and this one doesn't, hit it with PDAB, that pink will appear. So if you're questioning whether or not there was a stem flush there, that hint of color on the stem, hit it with some PDAB. and it'll bring it to life. And then, of course, if you're going to get deep into the identification of Russula, the last chemical up here you're going to need is some bourbon. Very helpful. This is an example of a sulcate margin. I know the word striate is thrown around a lot, especially around Amanita, but really when it's scooped out like you can see here, we should consider this sulcate rather than striate. There is a difference. So this is what I would call a sulcate margin. Size. This thing isn't even opened yet. This is Russula grata, and I mean it's huge. And this thing probably opened up to, you know, 6 inches across, maybe 5 or 6 anyway. Is that as important? That goes to that regional thing. I don't really know why we see them so much larger up north. And maybe it's my imagination. Gill spacing. This goes for any mushroom, of course, but what I do with Russula, and I do this with a lot of other mushrooms too, you know, because were they distant? You know, somebody says, well, they were kind of sub-distant. Well, come on, let's not break it down any further than we need to. So what I do with Russula is I take a United States nickel. If I can put it between the gills and not touch one on either side, they are distant. If I put it in there and I touch 2 gills, they are close. And if I put it in there and I cannot do it without touching 3 or more, they are crowded. It's the system I use. It's not official by any scholarly dimensions, but it works for me. A United States nickel, hey, if it works for you, use it. Give it a try next time you're in the field. Take a U.S. nickel out and say, hey, I see what he's saying. These gills are distant. Yeah, it's just how I do it. And then I don't do subcrowded and subdistant. I don't do any of that. I give them one of these 3 titles. Habitat is important. You know, if you're looking for Russula betularum out with your pin oaks, I'm going to tell you right now how many you're going to find. You're going to find 0. You know, some Russula are very host specific. Some of them are not. Some of them, if it's an oak, it's an oak. If it's a hardwood, it's a hardwood. If it's a conifer, it's a conifer. Some of them might be exclusive to white pine. So learn the habitat. I don't know how many tree species there are in Minnesota. There's 74 in Wisconsin. How many mushroom species? Probably 3,000. Learn your trees. It's a lot easier. It's a good starting point. This is Russula ventricosa piece. So this is in section ingrati within the Heterophyllidea. This is a really cool mushroom. It grows in association with pine, and it's usually buried in sand. So all of these were taken. Every photo I have of this mushroom was taken on Madeline Island at either Hidden Beach or Big Bay State Park, buried in the sand. You'll just see the sand lifted up a little bit, enough for the breeze to come through and blow a couple spores around. Kind of a fun one to look for. You might also run into Lacaria trulicata growing the exact same way. That's another sand mushroom. But here we're talking very habitat specific, sand with pines. I know they associate with, I think it's pitch pine out east, maybe, or I think it's pitch pine. I don't recall. Around here, I have found them with white pine and red pine, and I mean, there's no question they were with that tree. You know, when there's no other tree for a quarter mile, you pretty much got it narrowed down. So I have seen them growing with red pine and white pine. I've never seen them with jack pine, uh, but there's no jack pine where I know this mushroom is. So maybe they'll associate with any pine. But the sand is important. Stem flush. This is a Russula sanguinaria. Look at that beautiful stem flush. That's an important feature. Some species don't have that. Some have it where it's quite defined. This being one of those examples. Pretty little feller. Russula spores. My microscope camera is not the greatest, so I can't enter these in any beauty contests, but we do see warts. Where's my arrow at? Right there. We see warts here. We actually can see some little connector lines too. So these warts are amyloid, meaning that they turn that bluish black color in the presence of an iodine type reagent like Melzer's. So I hit these with some Melzer's and the warts appear. If I do them in, you know, like a KOH mount on the scope, I don't see them as well. They're still there, but you hit them with Melzer's and they are defined. Those warts can be isolated. They can be connected with little connecting ridges. They can be as high as, higher than 1 micrometer off the surface of the spore. And sometimes there's so many connectors that they form a full reticulum. The spores can be globose, as we see on the top here, or kind of subglobose or ellipsoid even. So getting a Russula spore under the microscope can really start to help us sort things out and see what the differences are. I do see a little bit of variation within the spores, but not as much. If it has isolated warts, it has isolated warts. The next one's not going to have connectors. When it has connectors, sometimes they have more than others on the same print, but it's another tool to help us get a little closer. And Russula has some friends, maybe some indicators to help you know that there's Russula present. The most recognizable one, of course, is going to be Monotropa uniflora, the ghost pipe. This is a symbiont with Russula, potentially a parasite on the connection between the Russula and its host tree. I know of 19 species of Russula that are associated with Monotropa, and I don't know how many there are fully. It could be hundreds. I don't know how many species of Russula we have. I have, without any question, 137 distinct species from my area in Wisconsin. And I probably have, I would say confidently I have half-ish. There's probably close to 300, I think, in our area. And I'm including Minnesota there, the upper Midwest. Out east, I think they have more. They've got a little bit higher tree diversity, especially through the mountains and especially down south. So how many do we have in the United States? I've seen estimates around 700. Yeah, that's probably pretty close. Yeah, maybe a touch more, maybe a touch less. But this is an indicator, at least that the mycelium is present. It doesn't mean you're going to find Russula, because these do come up first. The coral root orchids. I had to get this picture from Brooke Reed. It's the only picture I borrowed besides Bert and Ernie. And Chuck Norris, he wouldn't let me take his picture. This is a parasite on, or a symbiont. We better say symbiont because I don't think it's been really truly considered a parasite on Russula variata and Russula cyanozantha in the Heterophyllidea. It's definitely appearing before them. So if you see this in an area, hey, you know to look there for Russula variata if that's a mushroom you're after. Can we eat them? Many Russula are edible, but are they any good? I get asked that a lot. It's a reasonable question. I'm not discounting people that like to go out and forage mushrooms. It's just we hear it a lot. Hey, but can you eat it? Well, no, that's not why we're always here. You don't have to eat every mushroom we find. Uh, some of them are pretty good. Some of them are really flavorless, mild, and kind of soft textured. And I've tried a handful of them. Maybe I've tried a dozen. A couple of them I've really enjoyed. So like any other genus to follow, there are rules to follow. But the bonus we have is the lobster mushroom, or should I say mushrooms. We have two lobster mushrooms. We have our orange lobster and our green lobster. So the orange lobster is Hypomyces lactiflorum, parasitizing Russula brevis. We find it up here in the black spruce groves in quantity. On the right, we have Hypomyces luteovirens. And the host for this mushroom, I think, is Russula sylvestris and Russula fulvescens, because I see it with those two species. So fulvescens is the orange one. Sylvestris is one of our common red forest Russula. I can't be 100% certain on that, what the host is, but I will say that I do not have any of these in my herbarium because everyone that I've ever found has been eaten. This is a superior mushroom to the orange lobster, so if you find them, I encourage you to maybe just try a little bit your first time. But wow, they're quite good. They have a better texture and a better flavor than the orange lobster. There, I said it. I included this one. This is Russula parvovirescens. We've got a few in the Crustosa group in our area, probably maybe 5 or 6 species, and I've tried a couple of them. This one I find to be the best. It has a texture that holds up after it's cooked. and it has kind of a nice nutty flavor. It's a very good edible. That's the best picture I have of one too. It was the slugs know it's edible as well. Russula in death. Maybe some people would be interested in what eats Russula after it's gone. We've got kind of a cool Sizagites here on Russula pectinatoides in my front yard. This was quite a fungal display here. So, something has to break these down, put them back into use into the forest system. But the more commonly encountered one is, of course, Asterophora, Lycopodoides. What do they call it? The piggyback something, the powder puff piggyback, something like that. So I find this on Russula densifolia mostly, but I'm also seeing it on a mushroom that I am borrowing the European name Russula consobrina. It doesn't have, I know this mushroom doesn't have a valid name, and it's more commonly encountered than we think. I think it gets mislabeled as Russula adusta, but I'm calling it, CF consobrina for now. And I see this piggyback mushroom, the Asterophora, decaying the dead Russula, densifolia and consobrina. They are not killing the mushroom. They don't appear until the mushroom is dead. And they're kind of a cool little shroom, a fungus on a fungus. That's always fun. I do thank you very much for putting up with me for the last 45 minutes. Pay attention, take a little pride in your work, do some Russula work. Let me know what you come up with, and stop throwing them at trees every chance you get. Trent said you're allowed to do it once for educational purposes. After that, you don't have to throw Russula at the trees anymore.
We had a couple comments.
Okay.
Aaron Berg disagreed with you about the bourbon and said that he prefers Scotch.
Sure.
That the theory is that the mushroom is attracted to the peat and it allows itself to be ID'd easier. And my only other comment was that I really like eating those green quilted Russulas.
They're good. Yeah, for sure.
I think I can't tell one from another, but whichever one I've tried, that's the green quilted one. They're just delicious, and I feel like they're not confusing.
No, and there's not going to be anything dangerous in the United States as far as Russula goes. Within that compacted group, we do have one in Asia, which is Russula subnigricans, that has been implicated in a couple of deaths. But we have poisonous Russula here, but they're not going to be anything dangerous. That's why I say if you're going to try them, maybe try a little piece at first, just in case it infected something that we're not familiar with. But Sylvestris and fulvescens, those are the two that I think that's what they're hosting on. They're harmless mushrooms.
Does anyone else have any questions or have found anything interesting that they wondered what it was?
Also, thank you, Tavis. That was awesome. Yeah, really loved it. My question was kind of about the variations you were seeing. One time you had said to me something about, I think it was mushrooms with ash, correct me if I'm wrong, get more of the red color. And do you find that with the Russulas, that like reddening with the tree associate?
No. So, and what you're referring to there is aspen. So I see with our local fly agaric, I'm going to call it Amanita chrysoblema. I know some people will scold me for that. I see it with that, Clytopolis prunulus, and Boletus in our edulus clade. When they're in the presence of aspen trees, they have a tendency to show coppery reddish tones to the cap. Russula is whatever color it's going to be. I don't see any change within a species with different host trees. I don't think. I mean, maybe some get redder in the presence of aspen, but it's not the same red. It's kind of like this reddish glow that they get when they're growing with aspen, which is probably why out west they're calling Boletus mattii and Boletus rubriceps two different species, and they're probably not two different species. It's probably their host tree giving them that ruby color, and maybe I'm wrong on that too, but that's something I wrote that in my notes at least 30 years ago, that I noticed that when there was aspen present, especially in Amanita, you start to see those reddish tones. and I know they're the same species. I mean, it's our fly agaric, our Muscaria variant Guisaui. When it's growing with birch, it's bright yellow. When it's growing with aspen, it's orange. You know, when it's growing with spruce, it's yellow. If there's an aspen tree close by, it'll get a little hint of orange to its cap.
Yeah, and I've always found that really, really cool observation too, but then I mix up the trees, so good to get it back.
Who's talking, by the way? I can't tell.
Oh, that's Mariah.
Oh, hi, Mariah.
Yes. So folks, Mariah is the president of the Wisconsin Mycological Society and currently studying down in La Crosse. Let's see. Aaron is asking, can Asterophora lycoperdoides have fully formed gills?
Yeah, it can. And it's kind of interesting. You really have to cut into them to see them. And they might have like 3. There's not much to them. Or sometimes they're really, really short. So do a cross section and you'll see kind of the arch of where the gill is. That's fully developed. That's as fully developed as they get. I mean, I've never seen one where you flip it over and you can see gills, but there are gills there, and they are fully developed enough to produce spores, sexual spores. Yeah.
Yeah, Aaron is saying he found them both with gills and without. Both had the same size spores, both powdered on top after a day. Both nodulous.
Sure. So Asterophora also produces asexual spores. So it does produce in 2 stages. But yeah, the gills when they're fully developed, there's not much to them. They're not a very well-defined gill. I don't know if that helps or not. Oh, you have one that has gills easy to see. That's unusual, but it can happen for sure.
Tavis, I'm removing the spotlight so you can see who's talking if they ask a question. But I wanted to mention, Claudette and John Lamprecht mentioned that sometimes they find white lobsters, and wondered if you ever find them. And then Alan Burgo says he prefers the white ones.
So the white one is still Hypomyces lactiflorum that just hasn't got the orange. If you find Russula brevipees and it just has a tiny little spot of orange somewhere on it and the rest of it's been lobsterized and it's white, it's still a lobster mushroom. Yeah, and I think with what Alan is, what he's going to probably say is they probably have a better texture and maybe a fresher taste. That'd be my guess.
Yes. Perfect. John, did you want to unmute and mention anything? Oh.
Okay, there.
Hi, John.
I mean, it's something that we find actually pretty frequently in big woods. So, hopefully shortly we'll be picking those. And I mean, there's a lot of times where they're absolutely white. I mean, there's no orange coloration.
No orange at all. And I've certainly seen that, but
yeah,
I don't think it's a separate species of Hypomyces. I think it's still lactiflorum.
yeah, that's what we figured. And
Yeah.
I mean, they smelled about like that, except for the smell was a little fainter.
Okay.
So it was not as seafoody.
Sure.
I am curious about the green ones, the green lactiflorum. I mean, not lactiflorum, but
Luteovirens.
so
Yeah.
I'm gonna try to look for that a little bit more because I think I've stumbled across it and I just kind of went, well, this is interesting. And then I threw it at the tree. So
Sure you did. So with the green lobsters, what makes them a little bit trickier is you can't see it from the top.
yes, right.
You know, all you're seeing is a pink Russula on the ground and ignoring it as most people do. So if you want to find them, yeah, you have to tip them. You have to tip them over.
We did find
the
them
orange lobster, you see them.
I think we did run across them when we were out at the Nama in Colorado.
Yeah, and I wasn't aware that they existed out there until I gave the NAMA talk here in February, and Brooke said that they find them in quantity out there.
Yeah.
So that would eliminate Sylvestris as a host because I don't think that's a Rocky Mountain species. I don't think. I've at least never seen it out there. I see similar species, but not Sylvestris. So what's the host? Hard to say. Somebody was even talking about Zarepilina being a host out there. I have not seen that personally.
Oh,
Yeah, which would be a really interesting blend. A shrimp Russula with the lobster mold on it.
Cool. Yeah, and Lauren and Mariah were saying, I wonder if the white lobsters have the same concentration of dyeing pigment as the orange.
Oh,
No.
hit them with a little potassium hydroxide or ammonia
Oh, really?
would be the only way to know. But I don't know on that. I don't have an answer for that.
I have to say that I've never successfully saved them long enough to try dyeing with them because they stink so bad.
Well, yeah, they reek.
Like they stink so bad.
Rose was here a couple years ago, and she wanted the ones that were rotting. She said that they make better dye, and it's not a good smell. Yeah.
It's horrible. Yeah. I don't want to put those in my dehydrator. Cool. All right. Anyone else have any questions about Russula or anything else?
Why can't we throw them at trees, Tavis?
Yeah.
Because that mushroom has a purpose to serve. So you're allowed to do it once, according to Trent, for educational purposes. Other than that, look at the thing. Try to figure out what it is. Give them a little attention. Give them some love.
Or dispersal.
Yeah, any other questions?
Yeah. Can we throw them at other people?
That's fine.
well, we probably won't use the term jar as much after this presentation.
So the title for this, when I originally did it a few years ago, was called Not Jar.
Yeah. Okay.
Awesome. Well, thank you so much, Tavis.
Thanks for having me. Yeah.
Yeah.
All right. Have a good night, everyone.
You too. Thanks again.
you.
Thank you so
Bye-bye.
much, Tavis.
All right.
Thank you.
And